This presentation explains the concept of a small, innovative barge to address a response gap in the recovery of trapped but still mobile heavy oil within a coastline shore zone and other challenging locations where larger barges and oil recovery vessels cannot operate. It's also a resource for debris recovery. Its features and functions can support non-emergency day-to-day community businesses. Oil or debris is often only partially recovered offshore due to various circumstances, as this presentation discusses. It's either left to strand on the shore or the community is engaged with their small vessels and handheld equipment to recover the best they can. They're either hired to do so or are self-directed. Recovering this heavy oil or floating debris, such as styrofoam or noodles, is a worldwide problem, as it's messy, inefficient, and unsafe. The Shore Zone Micro-barge concept recognizes this problem and is part of the solution. EnviroEmerg Innovations Limited is an incorporated company established last year. It's an offshoot of my EnviroEmerg consulting services, in which I'm the sole proprietorship. My consulting focuses on emerging regional, national, and international environmental issues, primarily related to oil and hazard material spills, risk prevention, preparedness, and response. In particular, I specialize in shoreline claim assessment techniques known as SCAP for oil spills. EnviroEmerg's innovations are based on over 30 years of experiences and some of the identified gaps in ocean protection. The concept of a shore zone micro-barge is that it's a small, specialized, durable barge that can operate within the confines and challenging working conditions and environments such as coastal shore zones and its reefs, islets, crevices, and coves, among kelps, as well as within Arctic ice flows and within tundras and wetlands, and among watercourses and channels, and within tropical mangroves. These are locations where traditional large response barges and vessels cannot safely or effectively operate. There are also the locations where oil that is spilled and debris gather but are not often recovered, often left to strand on shore to cause prolonged ecological damage and increased response costs. The concept also applies to an uninterrupted, safe, and secure transport of the recovered products such as oil, debris, and other waste from the recovery site to a final disposal facility without intermittently offloading to temporary containers and tanks and other storage devices. As well, so as not to be a stranded asset, the Shore Zone Micro-barge incorporates various non-emergency functions to ensure community can use the barge between oil spill events and other spill events, such as serving in agriculture, harvesting, marine debris programs, and can be served and used as a scientific platform and many more other community uses. To define the issue, effective safe recovery of floating heavy oil as well as debris in the shore zone is a gap in spill response in Canada and worldwide. Often impacted communities are left with oil recovery and debris removal within the shores using their small boats, rakes, shovels, and buckets, but they still need a safe and clean place to put the product. The recovery of floating oil or debris is very much cheaper with lower secondary impacts to coastal ecologies and economies compared to cleaning when stranded on shore. The Shore Zone Micro-barge expands the tools available for an emergency. It fills a response and operational locational niche where community residents can use a resource that works with their small vessels, local knowledge of navigational hazards, and boating skills during an oil spill or when they have to manage the debris, such as from a container accident. The Shore Zone Micro-barge is purposely designed to manage a heavy oil challenge, particularly the storage and its transport. A heavy crude or residual oil, whether spilled from a vessel's bunker fuel or as cargo, becomes viscous through weathering processes, such as evaporation and emulsifications, as shown by these images. This creates a challenge to recover, store, pump, and transport. Impediments at any of these steps can result in curtailing operations, leaving the oil trapped in the shore zone, wetlands, or mangroves to be stranded on shore eventually. The following two slides examples two problematic types of oil. The first problematic oil. Recently, many international seagoing vessels have turned to using low sulfur fuel oils to meet air quality standards for sulfur dioxide emissions, while others have continued to use intermediate fuel oils and then scrub their engine exhaust to meet this standard. The traditional intermediate fuels, when weathered, are challenging to recover, but the physical properties of low sulfur fuel oils at the onset of a spill makes them even more difficult to recover on water, store and pump, and then clean the shores if they strand. This new oils are highly variable in the physical and chemical properties. Still, many have been shown to have a high viscosity owing to high pour points. That is, they become solid or semi-solid in temperate or cold waters. They become like grease or semi-solid butter. While most oil recovery devices, when recovered spill oil, the skimmers can draw the oil into it. Not so much so with low sulfur oils. Low sulfur fuel oils break into lumps, as shown by these images, greatly impeding on-water recovery. So the consequences are that the unrecovered oil can drift into the shore zone, leaving it to manually recovered by rakes, shovels, and buckets by people using small vessels and boats, such as skiffs, or reaching into the water from the shore. The Shore Zone Micro-barge is designed to meet these new challenges in a much safer, cleaner, and more effective way. Another emerging oil product is diluted bitumen. It's an unconventional crude oil from oil sands. Its physical properties at the onset of spill and from weathering makes it very difficult to recover on water, store, pump, and then clean shores. Diluted bitumen with its light volatile diluent, such as condensate, naphtha, or light crude, rapidly evaporates. This can delay the on-water response while safe air quality is reached, while at the same time it's rapidly weathering the oil and reverting back to its parent product, which is the bitumen. There's also a sweet spot exists where the volatile heavy oil ratio can accelerate rapid and extensive emulsification, as shown by the brown image. It then becomes too viscous to train in water and became tar-like, again shown as in this image from the bucket. Like most weathered heavy oil, they float but can tend to overwash or submerge under waves, making tracking and recovery very difficult. The same properties and issues pertain to unconventional crude oil derived from shales. All these physical properties and factors can lead to a viscous, thick oil reaching the shore zone, which is left to recover manually from small vessels while still floating or by workers on shore once stranded. The former is cheaper and less ecologically intrusive approach, but still needs a resource like the Shore Zone Micro-barge. The Shore Zone Micro-barge rises to the challenge of managing debris recovery. Styrofoams, noodles, and other small debris, such from a container vessel action, are insidiously damaging once stranded on shore and mixed into sediments. They are a challenge to recover from and can cause equal harm for decades. Oil spill response equipment, such as skimmers, hoses, and pumps, will either not work or perform very poorly when recovering, storing, and pumping weathered heavy oil. The result is unrecoverable oil is trapped within the shore zone or stranded on shore, requiring new tools and tactics. Recovered product, whether oil or debris, is often transferred and stored several times until reaching a final disposal facility or site. This can curtail offshore operations. The Shore Zone Micro-barge has a unique feature which it can be loaded with product, its hatch is sealed, lifted on a truck, and then offloaded to its final location. The product is offloaded by either opening its stern tailgate or by a valve. It is then returned to operational service. Essentially, the Shore Zone Micro-barge is the roll-on bin of the sea. The current state of technology and practices worldwide for heavy oil recovery in the shore zone and other difficult to reach places is to manually scoop the oil with rakes, shovels, and buckets, whether from a small skiff or reaching into the water from shore. Often this is an act of desperation by a community. knowing that offshore efforts have failed and the oil is stranding on their shores. The Shore Zone Micro-barge provides a safe, clean, effective storage and transportation solution that fits within a community's needs and resource capabilities. Case studies worldwide of practices to recover floating heavy oil, particularly when weathered and offshore oil recovery vessels have failed. 2002 Prestige oil tanker spill. More oil was recovered by hand tools working from small vessels of opportunity than the dedicated large offshore oil recovery vessels, as the weathered oil bogged down their skimmers, hoses, and pumps. Shore workers would wade into the water to scoop up floating oil, an unsafe practice. All the way back to 1969 and the California Santa Barbara oil spill rig blowout and that released crude oil, which actually started the ecological and spill preparedness movement in North America. And you can see at that time there were open boats, drums, and straw was used to recover oil trapped along the shore zone. Here we are back in California with the 2021 California Orange County oil spill. This was a pipeline incident. And here you can see that they're scooping up the oil with modified rakes and putting it into their skiffs. So, 52 years later, the only change in shoreline heavy oil recoveries are better personal protective equipment, the use of pads instead of straws, and a modified rig. It's still messy, inefficient, unsafe, and unhealthy for responders. Micro-barge is designed to work in difficult environments, from temperate coastal waters and shores to wetlands, mangroves, rivers, and on ice and snow. Vision and approach to the design and the function of the Shore Zone Micro-barge is to be used by a community for their day-to-day uses, so as not to become a stranded asset waiting for an incident. In the event of an incident, a community of people can converge and offer their services with their Shore Zone Micro-barges. This builds local response capacity and supports self-determination. Let's get into the nitty-gritty of the Shore Zone barge's design, features, and functions. It's a versatile design that has more than 50 well-thought-out features to ensure a reliable solution for managing recovered oil and debris in a variety of challenging environments. Many of its features are designed to serve multiple functions, enhancing its utility. It's adaptable to make it a valuable asset for community businesses. It's about 5.5 meters long overall, 2.3 meters wide by 1.2 meters high. A cargo capacity of approximately 4 cubic meters, provide a volume around 4,000 liters or 25 US barrels. It's large enough to be transportable in sea containers for the time. It's road transport compliant. It's sized to be towed by small community vessels of opportunities. Its height accommodates manual loading by bucket or hand of debris or oil. It has a connector system to accommodate a small oil recovery system operated by a tethered skiff to its side, so it's going to discharge the oil directly into a sealed barge. It would be constructed by high-density polyethylene, or otherwise known as HDPE, to withstand impacts, ensuring its durability in the most challenging conditions. This robust construction ensures low maintenance and easy decontamination, providing reassurance of its long-term use. It's meant to be worked near rocky shores, dragged on shore, over ice, snow, muskeg, and mangroves. The barge has 2 hatches that can be left open to accommodate super sacks or direct loading of debris or oil. It then can have sealed the hatches for transport of the recovered oil. A real key feature is its stern, whereby one can rear discharge fluids by a valve or solids by opening up a tailgate or flap. This gives it sort of the roll-on, roll-off feature, which includes that it has a bow hook and skids and the barge can be loaded by a roll-on truck or lifted by side hooks using a crane onto a flatbed truck. This allows a filled and sealed barge leaving the recovery site to be picked up by a roll-on bin truck or at a ramp, transported directly to a disposal site without opening, then discharged there with its tail flap, gates, or the valve described above. Such uninterrupted waste management reduces handling, spillage, and cost. The cargo hold is double hulled for added protection. The space between the hull is part of a steam or hot water heating system to soften tar-like oils to facilitate the removal, which is a high probability with low sulfur fuel oils spilled into temperate waters. The cargo hold's internal pumping system provides oil-water decanting at the recovery site so as to increase usable space for oil. Multiple Shore Zone barges can be connected by bow and stern hinge system to create docks and bridges that could accommodate people, ATVs, and a small truck. Crossing watercourses is a big task during an inland spill. The barge has several highly sealed compartments for its operational equipment that includes tarps, anchors, connectors, and more. There is even a dedicated compartment for electronics that includes a battery to operate incorporated built-in navigational lights, plug-in attachable work lights, as well as a GPS tracking system to manage the barge location sort of in near real time. The Shore Zone's Micro-barge is more than just an emergency oil and debris management tool. It can also be used for non-emergency applications. For instance, the oil-water decanting system can be used to depurate shellfish or run seawater through the cargo hold to keep fish or shellfish alive during sea transport. It can serve as a scientific platform for ocean monitoring equipment dragged on shore to support a community debris cleanup program. Community-based functions build a market opportunity and ensures the Shore Zone doesn't become a stranded asset sitting in a warehouse waiting for an incident. It provides self-reliance and determination by a community that has in that they now have a meaningful resource to offer or use during a marine incident, rather than just waiting on shore with their rakes, shovels, and buckets for the oil or debris to strand. Worldwide, the shipping industry has become safer with fewer spills. Nevertheless, spills happen, whether oil as bunker or cargo. The ecological damages from sea containers releasing nodules and styrofoam particles, let alone its other debris, has garnered global attention. In all cases, the tactics to recover floating heavy oil or debris that offshore efforts have failed to achieve and now trapped in the Shore Zone will often rely on responders using crude manual recovery tools such as rakes, shovels, and buckets from small vessels. Some mechanical handheld tools are available, but there's still no thought-out resource to put the product other than into barrels and totes on board a small skiff. Nothing has changed over the last 5 decades. The Shore Zone Micro-barge makes the change and rises to this challenge. Extensive thought has been written and written materials have gone into the design, function, and explanation of the Shore Zone Micro-barge to effectively and safely remedy the recovery of floating heavy oil and debris in diverse working environments and to offer a community a day-to-day tool. Ensuring that the barge is used between incidents and not become a stranded asset is a vital marketing feature to justify the cost. As such, multi and interchangeable functions are considered in its design. So, what I'm asking for is, what are your thoughts regarding both missions, regarding the oil debris storage and transport and the community utility of the Shore Zone Micro-barge? I'd like to hear from you. Thank you.